In this lesson, we will look at types of inorganic reactions and learn to classify a reaction as combination, decomposition, single replacement, double replacement, or combustion. We will also determine whether a reaction is an oxidation-reduction reaction and learn how to predict the products and balance a combustion reaction. Evidence of a reaction occurring can be rather unexciting, as shown in the beaker in the upper left. Some reactions have more of a spectacular approach with the flames we see on the lower left. We can see the formation of a precipitate or a solid coming out of solution. Sometimes we'll see the formation of bubbles or color changes, which also indicate that some reactions have occurred. The first type of reaction we will look at is a combination reaction. In this case, two or more molecules or elements combine to form a larger molecule. The example shown here shows sodium plus chlorine coming together to form sodium chloride. Decomposition is the opposite of combination. In a decomposition reaction, molecules break apart into two or more smaller molecules or elements. This example shows the decomposition of hydrogen peroxide to form H2O and O2. This reaction happens fairly readily when exposed to light. This is why a bottle of hydrogen peroxide that you might keep in your bathroom cabinet is stored in a brown bottle to block out light. If you have an old bottle of hydrogen peroxide, in all likelihood it's really just a bottle of water at this point. A combustion reaction occurs when something burns. When we have an organic compound plus oxygen, we form CO2 and water. While the identity and components of the organic compound can vary, we will always see oxygen as our second reactant, and we will always see carbon dioxide and H2O as products. The organic compounds can be hydrocarbons, such as the example shown here with propane, or they may also be other compounds which contain carbon, hydrogen, and oxygen. Other compounds can undergo a combustion, but these are the ones that we are focusing on. The reaction of propane requires oxygen as its second reactant, and it produces CO2 and water. Single displacement occurs when a free atom replaces an atom in a compound. In the cartoon at the bottom, we see a dog and a cat paired up, and on the product side, we see that the cat is no longer part of the compound. On the reactant side, we see a dog that's not part of the group, and on the product side, we see that the two dogs are now paired up. So the dog holding the roses displaced the cat in our dog-cat pair. An example of this is the reaction of HCl and zinc, which forms zinc chloride and H2. The hydrogen is replaced in the HCl by a zinc atom. A double displacement is similar to the single displacement, but in this case the cations swap their anion partners. Looking at our cartoon at the bottom, we have a burger and fries and a sandwich and an apple paired up. Notice that the fries and the apple switch places when we go to the product side. The same thing occurs in our reaction. The nitrate and the chloride ions switch places, so our products are AgCl and NaNO3. For both single and double displacement, you will sometimes see these called single and double replacement. The term replacement and displacement are used interchangeably and mean the same thing. Let's look at some examples to see if you can identify the reaction types. Our first reaction is NH4Cl forming NH3 plus HCl. The reactant is breaking apart into two smaller molecules, so this is a decomposition reaction. For number 2, cadmium nitrate and sodium sulfide react to form cadmium sulfide and sodium nitrate. Because we see the two cations are swapping their anion partners, this is known as a double displacement reaction. For number 3, we have N2 plus 3H2 forming NH3, which is also known as ammonia. Because we're forming a larger molecule from two smaller particles, this is a combination reaction. For number 4, we have chromium plus FeNO3 which produces iron plus CrNO3 The chromium takes the place of the iron in the iron nitrate compound and forms chromium nitrate, so this is a single displacement reaction. For number 5, CaO plus CO2 forms CaCO3. Two smaller molecules are coming together to form a larger compound, so this is a combination reaction. For number 6, we have CH4 plus O2 yields CO2 and water. Because we're adding oxygen and producing CO2 and water, this is a combustion reaction.